Today, we're going to review the problems that we did in last week's quiz. Students did very well in this quiz, so we're going to only select a few problems, which I think there are a few interesting ideas there. Even the problems are pretty simple, and we're going to expand those ideas. So let's look at the first problem. Fill 0.5 into the following 6 boxes without repetition. What is the maximum value possible? And the 6 boxes are, the first box represents a 1-digit number, the 2 boxes represent a 2-digit number, and 3 boxes represent a 3-digit number. Now this question, the best way to think about it is actually rewrite this into a vertical format. By that I mean that you write the sum as a 3-digit number adding a 2-digit number and then adding a 1-digit number. And you want this value to be as big as possible. So in this, you see that this digit represents 100. These 2 digits represent a tens digit, and these 3 digits represent unit digit. So to make the sum as big as possible, clearly you want the 100 digits as big as possible. What's the biggest number there? It's 5. And for the 10 digit, after removing the 5, you want these 2 digits, the sum, to be as big as possible. And the best you can do is put 4 and a 3 there. It does not matter you put 4 or put 4 here. So I can rather, let's say I put 3 and 4. It does not matter the ordering. But the idea is you want 3 and 4 there. And here, of course, the last 3 digits you can put on the unit digits. So 0, 1, 2. And the answer is 5, 7, 4, 7, 3. Right? So this is, in this problem, you are changing the way of looking at the problem. And I'm actually treating these digits as the true meaning of the digits, what the digits really mean. This is basically the place value of those digit. This is a 100 digit, this is a 10 digit, and this is 1 digit. That's problem number 1. Let's look at problem number 2. Fill 5, 6, 7, 8 into the following 4 boxes without repetition. What is the minimum value possible? Now I have 4 boxes here. Instead of representing a 2-digit, they are all single digit here. This box times this box plus this box times this box. Now, when you think about this kind of question, the first thing coming to mind is a symmetry. In here, all the 4 digits are symmetric in the sense that it does not really matter where you put the 8, because, say you put the 8 here, put the 8 here is the same as put the 8 here, and these 2 terms multiplied does not really have ordering, right? You can put this one in front or as a second term, does not really matter. So without loss of generality, because of symmetry, I always can put 8 here. Now the question is, what is this number? Because now this is the only degree of freedom, so to speak. If you decide this number, these 2 numbers are automatically determined. So what is this number? Now, one way of doing this is just trying an error. You put 5, 6, 7 into this, and to see which value is the largest, or actually in here is the smallest, and that's your answer. And turns out to be you want to put 5 here, the smallest into here, and 6, 7 to be here. And you get the answer to be 5 times 5, 8 times 5, and plus 7 times 6. You want the biggest to be paired with the smallest and the middle number multiplied together. But in here, I'm going to introduce a principle. Here is a way to think about in a more general fashion. So assume that I have 8, and here, actually by bad luck, I decided to try 5 first. And I only need to determine between 6 and 7 here, or 7 or 6. Basically, I'm fixing two numbers. I only need to decide choosing either putting 6 here or 7 here. Now this is, of course, you can just plug in and to see which one gives you a smaller value. And the idea is, clearly, if this number is bigger than this number, I want to choose a smaller value put here and a bigger value to pair with the smaller value to give you a smaller total sum. So the observation you found is by fixing 5 and 8, 8 and 5, you want to pair the bigger value with the smaller. Right? So you put a 8 with 6 and 5 with 7. Okay? But this observation can be again be used by, if I already have 8 and a, let's say 6 plus 5 times a 7. Now, assuming that 8 and 7 are fixed, I'm determining between, I'm going to pair whether I need to switch this 5 or 6 or not by using the same observation. Because if you can switch 5 and 6, because 8 is bigger than 7, I want to pair 8 with the smaller number, which is 5. So this, again, I can improve by doing 8 times 5 plus 6 times 7. And the idea here is basically you're fixing two numbers except the last two. You're fixing all the numbers except the last two, and you only need to determine or decide for these two numbers what is the better choice. And you just keep doing that and to arrive this minimum value. And this idea, I call it the incremental improvement. And the idea is extremely useful to solve a lot of problems. Now I will give you an extension of this similar problem to this problem. Let's say you have numbers are 1 to 10, okay, 10 numbers. And I want you to find the smallest value such that for this pair of sums. Okay, you have 5 pairs numbers multiplied together, and I want you to see what is the smallest value of this. Try to using this incremental improvement idea, because a brute force trial and error is going to take a lot of time. And also, just from this form of summations, I think you can come up with different forms and try this idea as well. So that's for problem number 2. Now let's look at problem number 3. Jordan thinks of a 12-digit number such that the sum of any 3 consecutive digits is 17. If he divides number by 100, the remainder is 17. What is the leftmost digit? So make sure you understand this. When he divides a number by 100, the remainder is 17. What does that mean? It means that the last 2 digits is 17. And then using the sum of any 3 consecutive digits is 17, that means by working backward, that means that 100 digits is going to be something such that adding 1 and 7, adding this, is going to be 17. And clearly this can be 9. And what is the thousand digits? Again, using the fact that the sum of any 3 consecutive digits is 17, you get this is 7. And again, this is 1, and you see the pattern. So it's going to be 7, 1, 9, 7, 1, 9, 7, 1, 9, 7, 1, 9. And the 12th digit, if you just write it down, is clearly going to be 9, right? Or you can do is for the 12th, because you see the pattern repeats after 3. So for multiple 3, it's going to be 9. For multiple 3 plus 1, it's going to be 7. And multiple plus 2 is going to be 1. So in this case, 12 is a multiple of 3, and the digit is going to be 9. Okay, so this problem, the basic idea is write down, find a pattern, and then what matters here is only going to be the remainder divided by 3, because the whole pattern repeats after 3. And there are many similar questions like this. For example, what is the unit digit of, let's say, 7 to the power 2019? What is the unit digit? And for that kind of question, you just write down the unit digit for 7 to the power 1, 7 to the power 2, 7 to the power 3, 7 to the power 4, 7 to the power 5, and so on. And then you realize there's a pattern of this unit digit in accordance with the exponent. So a different way of saying it is the unit digit as the exponent goes from 1 to 2019, the unit digit actually repeats after 4. And so that what matters for the unit digits is only going to be the exponent divided by 4, what is the remainder. And that's basically, it's the same question as this one. And there are many such questions. All right, this is the review for this test.